In this video, we're going to create the basic character controller for our game. But before I do that, I said in the last video I'd show you how to turn on backface culling in Godot. And what you want to do is go ahead and open your material, go to parameters, and cull mode should be back. Although I've only done that for the floor and the wall and the ceiling, because the walls are fine. It's kind of weird when the walls disappear. So I put the cull mode for back onto the wall and ceiling material. All right, so I can close that, and I'm not going to save that because we'll come back and use that test level later on. Instead, what we're going to do is we've got a new scene here, and we're going to go ahead and add in a kinematic body. Now, this tutorial I put together using a variety of sources. So you'll notice if you've been around any kind of Godot resources or programming things on YouTube, there's a few really good ones out there. And I've looked through heaps of them. So there's the Kids Can Code, there's Garbage or Garbaj. There's also Ms. Is. And kind of this tutorial is put together from a few things from them, some of my own stuff. So some of it may look familiar, but credit where credit's due. Go check out those sites as well. So what we're going to do here is I'm just bringing up my other project so that I can see it and remember it. So let's go ahead and we're going to go into creating our kinematic body, which we're going to rename to player. I think it's important to name nodes, especially ones that you'll be referencing from other scripts. Things that you won't be referencing that much, you can just leave at the default value, but we will be referencing the player node. Now, the player needs to have some kind of collision in there. So we're going to go ahead and add in a collision body. Oh, by the way, what a kinematic body is it's a physics object that doesn't have physics applied to it unless you apply it manually. So it's not like a rigid body where it automatically has gravity. The kinematic body will just kind of stay static, but it will interact with other physics bodies. So we've got a collision shape here, and this is going to be a, we're going to go with a, let's see, we're just going to go with a cylinder shape, I think. Now, no, we don't want a cylinder shape. We want the capsule shape. We do want the capsule shape. And we're going to go into the transform for this and turn it 90 degrees on the x-axis. So it's like that. And I think that the size for this is probably a bit too wide. So I'm just going to bring it in. So it's kind of like that. But then I'm going to bring it up to there. So I roughly want the bottom of it kind of there. I'm going to just bring it up a little bit because we're going to put something else below it. So that's going to be it there. Okay, so it's kind of big. We'll play around with that shortly. The next thing we're going to add is another collision shape. And this is going to be a box shape. Now this box shape I'm going to bring down and I'm going to resize in and in like that. Now the exact measurements of it are not that important, but I roughly want it to be about 1 unit wide. So that looks to be close to 1 unit wide. If that's 2 units wide, then it's about halfway there, halfway there. That's all good. Now you might say, why have we got 2 collision shapes? And it's pretty straightforward. It's because one of them is going to be the feet and the other is the main body. If we just put this as the main body, then what happens is when you get close to an edge, you kind of slide off. But with this here, it'll make it so we drop off. Now, of course, I could use a cylinder for the feet, might make more sense. I was going to use a cylinder for the whole body, could do that as well. I'm just going to use 2 separate parts here. Now we're going to add in a pivot and not a pivot, sorry, just a spatial node, but we're going to call it pivot. And this is what's going to attach, we're going to attach our camera to, and we're also going to attach our gun to it as well. I'm going to go ahead and bring that up roughly to about where eye level would be. So close to there. I'm actually going to make this a lot thinner. I want to keep the height, but I want to make it kind of thinner. Like that. That seems pretty good. I may have to play around with this. It may just be way too high. at the moment. It's kind of difficult to tell, so we'll just leave it at that. And this cube, make that a little bit smaller, bring it up. It's not important. But we've got our pivot here and we want that to be at about eye level. So I'm going to bring that up to about there. Okay, and then we're going to go ahead and add in a camera. The default values for all of these, by the way, should be fine. When I say default values, I mean the rotation. We want the camera looking into the negative Z, which is up there. Okay, so I'm going to bring that up. I'm actually going to delete that and add the camera as a child of the pivot, so it goes straight into there. And I'm going to also add in another node, another spatial node as a child of the pivot, and I'm going to call that gun. Okay, what we're going to be doing is this node here, later on as we switch guns, we're going to basically unload and load different scenes from here, because each gun's going to be independent. We could just have them all visible and hide and reveal different ones. This is going to be more confusing. So the way I'm going to do it is each gun is going to be a separate node, a separate scene, and we're going to load it and unload the previous one, whichever one is loaded in here. It's worked out pretty well for me so far, so that's all good. So what we've got here is our basic player. Okay, so let's go ahead and add a script to this. I'm going to call it player. We'll save this first, sorry. I'm going to save this into a folder called scenes. And I'll save that as player. That way when I add the script, it goes into the scenes folder and we create it. Now we can delete all this. And let's have a look at what we need. So I just have to remember what is actually important in this script, because I've written a lot more than what's necessary. So we definitely need velocity. This is the movement vector of our player. So it's going to keep track of that. In func_ready, we're going to put in this code, input.set mouse mode and input.captured. We're going to capture that mouse, so we can't leave it. And that way it'll kind of capture it to the window. It means we have to Alt F4, at least for now, to quit the game. And then we're going to go ahead, we're going to add in a few other functions. We're going to add in get input. We're just going to put the functions in that we'll need. We're going to add in unhandled input. And underscore physics process, put that in pass, and there's a few others. We'll come back and add some of these later. Change gun, say gun, pass, and then underscore process, delta, pass. All right, so these are the functions here. Let's go ahead and just do our input first. So our input code, we're going to declare a variable called input, direction equals vector 3. So every time this code is run, it's going to create a new variable called input direction. It's going to be a vector 3. Then we're just going to get the input code. So if input dot is action pressed, and I'm going to make these in a minute. So we're going to say move forward, colon at the end. This is very Python-like, by the way. Input direction plus equals negative global transform dot basis dot z. Now let's just, before we go on from here, let's go back to the 3D view. So the transform basis, the global transform is this object's position in 3D global space. Okay, and then the basis is, I'm not going to explain this correctly, but I'll try to explain it in a way that makes sense. The basis is its local transform's z-axis relative to its global transformation. So what I mean is currently this is at z-axis, and so when we push up, it's going to travel along that. But as this player rotates, this way here is now its local z-axis. And if we keep rotating, That way is now its local z-axis. It doesn't update on here, but it has updated in the object. And so that's what we will be using to move it. We don't want it to just move along this path when we push up. We want it to move the direction it's facing. So that's what that basis.z does. I'm not sure if there's a way that I can switch this to view it as local, or switch the grid. There may be. You'll just have to trust me that that's what this does here. So let's go ahead. If input dot is action pressed, move back. These actions don't exist yet, by the way. We're going to create the actions in a minute. That's going to be minus equals negative global transform dot basis dot z. We could also say plus equals. Just going to say plus equals actually, and take the negative off there. That would be fine as well. If input dot is action pressed. So what this is doing is it's accessing the input class in Godot, checking is an action pressed, which means is the key held down, and then we're doing something if it is, which is just changing our input direction. Input direction plus equals global transform dot basis dot x. So this is the strafe, and this is going to be negative here. And I'll just copy this so I don't have to write it all out again. Hopefully my noise gate is working this time and you can't hear my keyboard smacking because it's really loud. Strafe right, and we'll change that to the positive version of it. So if we go back to here, this is the x-axis, this is the z-axis. In Godot, y is up. In Blender, z is up. However, it does convert it, so you don't need to worry about trying to build your model sideways in Blender. And so x is going to be our strafing. So we've got this part done. Let's just check one more thing. We'll get our movement happening for our character, and then we can test it. So in here, the physics process, we're going to first add gravity. So let's go ahead. I'm going to add a comment. Code comments are pretty important. Gravity makes sense. Plus equals, we're going to need gravity variable. I did actually miss a whole bunch of variables at the top, which we'll go back and add in a minute, but gravity is going to be one of them. So gravity times delta. Let's go back here under velocity, var gravity equals negative 30, var max speed equals 8, and var mouse sensitivity equals 0.002. So these are some values that I've played around with. There's some other things we'll come back with later. Let's just go ahead and add some code here. Basic variables, add some code comments, I mean. And then down here, I'm going to add gun variables. We haven't put those in yet. I'm going to add code functions. So the gun variables we'll come back and put in later. We haven't made those yet. We don't need to worry. So what this line of code here does, velocity plus equals gravity times delta. We've got our velocity here, which is a three-dimensional vector telling us which direction we're going to move in 3D space. And we want it to move down. We want it to fall. Okay, now it's not going to fall through an object, but then we need to go var movement. We'll call it desired velocity. I know this is I'm trying to kind of rename variables, but it doesn't matter. Get input times max speed. One thing I made a mistake. I didn't type return input. Duh. Now just on this line here, the line just above return input direction. If you don't want the player to be able to strafe run, so if they strafe, they go faster, you can put this line in. Input dir equals input dir dot normalized. Okay, and that will get rid of strafe running. Add to cancel strafe running. If you want to leave strafe running in, don't put that line in. You'll be able to run really fast if you're strafing. It's up to you. Preferences. Okay, so desired velocity equals get input times max speed. And then we set up our velocity.x equals desired velocity.x, velocity.y equals desired velocity.y. Sorry, that should be z. My mistake. And then velocity equals move and slide velocity vector 3 dot up. I'll explain this in a sec. True. So what we've got here, we're getting our gravity. We're adding our gravity to our velocity. We're saying get the velocity, the desired velocity that we want to move is that times max speed. We're going to set this here. Velocity.x equals that. Velocity.z equals that. And then we're going to use velocity to move and slide. Now this will store the remainder of it. It's like a frictiony kind of thing. I don't fully understand how that works, but it is optional. If you just write move and slide, it will work as well. Velocity, and this is the up direction, so it knows which way to check on the ground. And true is stop on slopes. I think that's what that means there. So we can actually test this now. Now to test it, we need to do one thing. We need to, and this video is getting long, so I just want to stop in a minute. We're going to test this by creating one more scene, and this scene is going to be our test room. So it's actually going to be, it's going to be our test room. So let's go ahead here, find our test level and double click it to open it, create a new inherited room. So in here, we need to do a few things. We need to click on this and we need to click mesh, create tri-mesh static body. It's going to give us a tri-mesh static body so that we can actually see through it. I was going to make this see-throughable, so I'll do that now with the floors. I'll go parameters, cull mode back. There we go. And now I need to save this. We're going to add some more stuff to this test level later, such as navigation mesh and whatnot. I'm going to save this. I'm just going to call it test level again, put it in there. And then in an empty scene, I'm going to call this world. And I'm going to put in the test level. So we're going to go to scenes. We're going to bring the test level in. So there's our test level. And we're going to bring the player in. There's our player. We're going to move the player somewhere. Now the player is currently either too big or the test level is too small. So this is kind of some trialing stuff. We need to trial it and find the right size scale for our test level. It may be better just to scale down the player, or it may be better to scale the level up. I'm going to scale the level up. So to do that, I'm going to go to test level, go to transform. I'm going to scale it to 1.3 on all axes, like that. And save that, go back to here. It looks like everything's changed. So I will then save this as world. I'm going to test it. We've got an error. That should be times equals, I think. No, it is definitely plus equals. Gravity equals -30. Why have I got an error there? Oh, it's my mistake. Velocity.y. Okay, there we go. So I'll run this scene again and can't move, can't look, nothing's happening. And I know why. Project settings, input map. I haven't added any of the actions. Let's go ahead and move forward, move back, straight left, straight right. And I'll go down here. I'm going to add keys for all of these. Key W, key back, key left, key right. Let's test this out. Nope, I want to use this one. There we go. I can move around. And I can't do any mouse look yet, but we'll get to that shortly. But it is working for now. So I can move. It does look a little bit jerky on my screen. It may just be because of the screen recording. But that's it. So we've got our test room done. We've got the player controller kind of done. There's a lot more to do with this player controller, but this will bring us to the end of this video.